So we'll start with difference equations. Okay, so as I wrote you already, let us start with this equation. Xn plus 1 is 2xn. So we saw that x1, suppose x0 is 0.1, then x1 is 0.2, x2 is 0.4, x4 is 1.6, okay, x5 is 3.2. So you can see that the values of xn increasing as n is increasing. Yes, do you agree? The value of xn is increasing as n is increasing. So what should be, how xn should behave as n tends to infinity? Anyone? What happens to xn as n tends to infinity? How? How much? Yeah, but then what should be the value? Like how it can tend? So what that is? No. So that is, so xn is going to infinity as n tends to infinity. So xn is diverging. Xn is diverging. Now let us look into another example. Xn plus 1 is 0.5 xn. What is, suppose x0 is 0.1, or maybe I will make it bigger too. X0 is, so what is x1? X2? 0.5. Yes. What is x3? X4? Okay. What is x6? So you can see that it is oscillating. You can see that, can you see a trend of values? First, it increased to 1. Huh? Are you sure? Then what is 0.0625? Good. Yes. Then what is this one is correct? Then this one is also not correct, 0.125. Okay. Okay. Anyway, so you can see that the values are decreasing. You can see that the values are decreasing, and whatever you do, the values are not going more than 1. Whatever you do, the values are not going more than 1. Isn't it? So can you predict what should be the behavior of xn as n tends to infinity? Yes. Xn is going to 0 as n tends to infinity. Now, what happened to both of these equations? What happened to the first difference equation and second difference equation? First difference equation tended to infinity as n tends to infinity. Second difference equation went to 0 as n tends to infinity. So when you are modeling any infectious disease problem, you always want the second case, where the number of infectious disease under a particular vaccine should go to 0 as over a long run. After 2-3 months or something, you have to predict something. So the idea is what made these two equations give different qualitative behaviors. What made these two equations give you different qualitative behaviors? Any ideas? First one is going to infinity, second one is going to 0. What is the coefficient difference? Xn plus 1 is equal to xn. X0 is 0.1. What is x1? X2? It is always staying constant. So xn is going to 0.1 as n tends to infinity. Always staying in the same zone, same steady state. Now the question is, what makes these three differ qualitatively? What makes these difference equations behave qualitatively different? Coefficients. Yes, but can you make a trend on these coefficients? Yes. Yes. Exactly. Exactly. And this number is something very special. This number is something very special. This number is nothing but the value of the derivative. Can you take the derivative of the right hand side? 2. That is the coefficient, nothing but the derivative. What is the derivative of this? What is the derivative of this? Yes, exactly. So if mod of f prime x, if you have xn plus 1 is f of xn, so this is the theorem. If mod of f prime x is less than 1, then xn plus 1 equals to f of xn will reach a steady state. Will reach a steady state. If absolute value of f prime of x is greater than 1, then xn plus 1 equals to f of xn will diverge. Can you see that it is making the stretch? When you take 2, when the derivative is 2, mod prime f prime of x is 2 greater than 1, so it is diverging. If mod of f prime x is less than 1, which is the second case, you see it is reaching a steady state. Okay, it is reaching a steady state. Fine. Okay. Fine. So here f of xn, this f of xn, actually this is linear case. I told you about all linear cases. Even in non-linear case, even in if fx is non-linear also it works. If fx is non-linear also, this theorem will work. Okay. Fine. And that is, it converges to a steady state. There is nothing but a fixed point of this mapping. Okay, fixed point of this mapping is nothing but a variable x star for which f of x star is x star. Nothing else. That means it will be staying there. Whatever you do, it will stay there. It won't move anywhere else. That is a fixed point. That is what is fixed point, right? Like if I move him, he won't move. He will be staying there. It is a fixed point. That is the definition of fixed point. Okay. But we are not going to discuss that here in this course. Okay. Fine. So, okay. The idea is simple. Now let us come to a bit formal definition of these difference equations and all. So suppose, so this definition, suppose you have these indices xn plus 1, so on till xn plus k be a set of, how many points are there? Can you calculate how many points are there? Xn to xn plus k. How many points? Be very careful. Yes, k plus 1. So suppose xn plus 1 up to xn plus k be a set of k plus 1 points. K plus 1 equispaced points, okay, with spacing h. With spacing h. So what do I mean by that? If xn is 1, then xn plus 1 is 1 plus h. Xn plus 2 is 1 plus 2h. So, yes, that is what I meant by equispaced points. And suppose corresponding to each of these points, suppose we evaluate the function at those points. And those points I am telling you as un plus 1, so on till un plus k. Okay, be the values of the function, at these k plus 1 points. That is nothing but u of xn. Un is nothing but u of xn. Agree? Now, a relationship between un and the differences Now you will know why it is called a difference equation. now you will get an understanding why it is known as difference equation. A relationship between un and the differences, that is delta I un, okay, where I is belonging from 0 to k. Here I am adding 0, right? N plus 0. Yes. I is going from 0 to k is called as a difference equation. Okay. Is called as a difference equation. Is called as a difference equation. Fine. Now I hope you know about this delta I un. Do you know about delta I un? You know actually, but you might not know this notation. Okay. But we'll cover that. We'll cover that. So a difference equation is nothing but it connects the value of u1 with nearby values of that with the differences. So what is delta u, delta ui, delta u1, u1 minus u0. Delta u1 is nothing but u1 minus u0. What is delta 2 un? What is delta 2 un? Use the idea from partial derivatives. Right hand side plus 2 times the whole plus the left hand side. Okay, so like that. So this is known as a difference equation. Actually, if you note in ODE also we do it. In ODE, what happens? Du by dt is depending on you. Du by dt depends on you. Du by dt depends on you. Yes. So in difference equation also it is happening. So therefore, you know now why it is known as a difference equation. We will come to that, how a difference equation looks like. Then maybe you will get a better understanding what is a difference equation, why we call it as a difference equation and so on. Now we call something known as the order of a differential equation. Do you know order of a differential equation? Now similarly, we have an order of a difference equation. What is order of a difference equation? Order of a difference equation. Order of a difference equation is the number of steps. So it's equal to the number of steps number of steps between the farthest subscripts. So number of steps between the farthest subscripts. Okay, that we will see. That you will see. What is it? So suppose if you have a difference equation involving un plus 2 and un, what is the order? This is the farthest subscript and this is the initial subscript. So it is nothing but n plus 2 minus n, that is 2. So the order of the difference equation is 2. Because the order is involving, the difference equation is involving un plus 2 and un. So farthest subscript is n plus 2, least subscript is n. Take the difference, that is 2. That is the order of the difference equation. Okay, fine. So how a difference equation looks like? So a general form of a difference equation. So general form of a difference equation is a general form of a difference equation is, can you tell, f of u1, u2, so on up to un, okay, plus k. Sorry, I should have written n plus 1, so on up to n plus k equal to 0. That is the form of a difference equation. All about those relationship between the variables given to you. Equispaced variables. Those, but keep in mind, those should be equispaced variables. un plus 1, un plus 2 up to un plus k, all equispaced. Cannot work with non-equispaced variables. Okay. Fine. So let us see one example. Yeah, let us take an example. So this is a difference equation. This is a hard looking difference equation, but you can actually solve it. So delta 2 un plus 3 delta un plus 5un is equal to 0. What is the order? What is the order of this difference equation? Any ideas? No, you don't just look into this 2 and tell it's 2. You have to solve it. You have to compute the what is order. Order is the relationship between the farthest subscript to the old subscript. So can you substitute what is delta 2 un? Delta 2 un is nothing but un plus 2 minus 2 un. Am I writing it correctly? Un plus 2 minus 2 un plus 1 plus un. Agree? So delta un is nothing but un plus 1 minus un. Can you substitute this and into this equation and tell me what is the final value you are getting? Final value is 2. Wow. So you will get the final answer as this. Un plus 2 plus un plus 1 plus 3 times un equals to 0. Is it correct? So what is the order? Take the farthest subscript n plus 2 minus the lowest subscript, that is n plus 2. So the order is 2. So order of this difference equation is 2. Now what is our job? What is our final step? Our final step is, if this is the equation, how the finance change, finance of future, finance 2 years later, the value of Durga, Miss Durga, value of Miss Durga after 2 years depends on value. She has 3 times the value now plus 3 times the value next year. So what should be the value at nth year? Your interest is to find un. What is your interest? Your interest is to find un. Yes, so that you can predict what happens to her income as n tends to infinity. If you have income now, if you have income, suppose I have income of 10,000 rupees now in my bank account, 10,000 rupees. So now what should I do? After 2-3 years or after 10 years, what should be my value? That I can compute using this difference equation. Why are you laughing? What is this? You give your example, we'll calculate it. Okay. So this is the idea of a recurrence relation. This is also known as recurrence relation and also difference equation. So this is this is known as the order of a difference equation. But what is our role? Our role is not finished yet. Our role is how to find, how to compute un. This is the question. This is the question we will try to answer in subsequent classes. This is the question. So we will develop methods through which we can solve un, isn't it? So we will develop techniques through which we can find un. That is our idea. Okay, so similarly, let us consider now a generalized. So this is the aim of this module. And to be honest, the theory part will look a bit more difficult, but you don't need to understand the full theory part. You just need to see it. You just need to understand it a bit. And then we'll do 3-4 problems. And you will see easily that you can solve any equations given to you like this. Believe me, when I give you 4 questions, by the time you will finish the theory part, you will be confidently solving all the 4 questions. Okay, can you now let me ask you. Now let me ask you, what is un? From this equation, sorry, From this equation, what is un? Can anyone predict? When I gave you un plus 1 is 0.5 un, everyone predicted un is nothing but 0.5 to the power n u naught. Yes. So for n tends to infinity, people, you are able to predict everything that it tends to zero, all the things. Now my simple question is, if I give this to you, if I give this to you, how will you be able to solve it? That is my question. Seeing this, can you tell me the behavior of un? How un is behaving as n increases? How? Tell un, yeah. Yeah, how the behavior of un according to this recurrence relation? Do do. Huh? Coefficient is 3. Huh. Okay. So you are telling that un tends to infinity. Un will tend to infinity. Can you code it in Python? Can you code it in Python and let me know that you are getting exactly this or not? You should try and let me know. And maybe we'll solve this question also later and prove it that yes, whether it is happening or not. Okay, let us come. So this is our aim. This is our aim of this module, to do this only. Okay, and that's where after solving this, we'll finish this module and courses. Let us come to the basics. So now we have to strengthen our fundamental and develop methods through which we can get the solution. Okay. So let us generally write. Now we will write everything generally and then we will come to the concept. Suppose you have this difference equation. It is not necessary that it will be multiplied always by 1. It can be multiplied by any constant a naught. A naught un plus k, a1 un plus k minus 1, so on till ak un. Yes, is equal to some gn. It can be some gn. So what is this remind you of? Non-homogeneous difference equation. Non-homogeneous difference equation. So remember that if I tell you un plus 1 is 0.5 un plus n square, then what is the behavior? Then what is the behavior? We don't know. We don't know because you can see that you can write it in this form. So can you see a relation between this form and this form? Can you see a relation between that form and this form? You can see that a naught is 1 here, 0 minus 0.5 is a1 that I have multiplied with un, and gn is nothing but n square. Gn is a function only depending on the value of n, a variable n. So it can be n square, n cube, any log n, anything. So this exact same thing I think is used in your data structures. So towers of Hanoi also we will cover in next class, an application of this difference equation. But I remember this carefully, like when I learned data structures, I came to know that these difference equations are important because you want to predict what is the complexity of that program. And Tn, order of n, Tn is order of n square. Like that you will see after you find the solution. Okay. So difference equation will be able to tell you the order of accuracy of your code, whether it is order of n square, like time complexity, time complexity of your code, whether it is order of n square number of multiplications or n cube number of multiplications, you can see. So you can compute what is the value of un in general, and if that contains n square n cube, if that contains n square n cube, so can you tell me what is the complexity of that code? If n square is there, n cube is there. Yes, order of n cube, you will take the bigger one, order of n cube. So therefore, how you will compute this un? You have to know the methods, and that's what exactly this module will do. You got the idea? You got the relations between where it can go to. Okay. Fine. So this is, and A naught is usually not equal to 0. A naught is not equal to 0. Okay. A naught is not equal to 0. Fine. So this is the standard form. This is the standard form of difference equation. So this is the standard form of difference equation. Linear difference equation. Okay. So now if Gn is not equal to 0, it is homogeneous. Oh, sorry. If Gn is not equal to 0, it is non-homogeneous. Yes. Because there will be a time-dependent term. Now, if Gn is equal to 0, it is homogeneous. Because there is no time-dependent term. Homogeneous difference equation and non-homogeneous difference equation. Similar to this, what I would say, your differential equations. Similar to today's differential equation, we solved non-homogeneous differential equation also. Okay. So as in ODE is same in difference equation. So what we had in ODE, can anyone tell me how we solved non-homogeneous equations? How we solved non-homogeneous differential equation today's class? Yeah, decoupling. But I told you, remember that I told you two solution. One is the homogeneous solution plus the particular solution. UN plus UP. Isn't it? Therefore, we computed eigenvalues, eigenvector, we solved it one part, then we added the non-homogeneous term and solved for the particular equation. So same here we will have UN is nothing but UN of the homogeneous part plus UN of the particular equation, that is the non-homogeneous part. So this UN is nothing but the general solution. This is nothing but the general solution. This is the homogeneous solution. Homogeneous solution. This is the particular solution. Agree. Agree. Okay. So this is what we will plan to solve in this module. Anyway. So this I think we can start as a fresh class because it will continue to be a theory. It will continue to be a theory session. But actually what we, I will tell you, like we will do with all these matrices. Okay. So this matrix is something special. Okay. We will learn about something known as this criterion, that is. It's very, very important criterion. Like it pops up everywhere. It pops up everywhere. Because the idea is simple. The idea is, the question is this. So why we need so many big matrices and all? The question is, if you have this characteristic equation coming from A minus lambda equal to 0, this came from characteristic equation. Okay. Z is nothing but you can think of eigenvalue. Okay. So this polynomial equation you are seeing right now will have roots. Will have all k roots. Exactly. Yes. Yes. Agree. Now the question is, what is the condition that all eigenvalues will be less than 1 in magnitude? Because then only your system, your recurrence equation is stable. You only told me that if it is less than 1, it is stable, right? It is going to steady state. So we should know, do we have condition when all eigenvalues are less than 1 in magnitude? Okay. So when we can have all eigenvalues less than 1 in magnitude? All eigenvalues less than 1 in magnitude. When can you have all eigenvalues less than 1 in magnitude? For that, you have the Hurwitz criterion, Routh-Hurwitz criterion. Actually, you can make a matrix of this coefficient A1 to AK. And through this study of this matrix, there are some conditions. If those conditions are satisfied, you can claim that all eigenvalues are less than 1 and my financial condition is stable. If your is not diverging to infinity, it is stable, right? So you can predict. So that will come in the next class. Okay. That we will derive in the next class. So next class will be a bit more theoretical. But after doing that theory, you can actually solve these kind of questions that find the generals, find un where you have this equation. Where you have this equation, you can actually find what is u1 based on this equation. Once you solve these methods, and more importantly, is the solution bounded? So after you learn the theory, you will be in a position to solve this. And believe me, the solution is just 4-line answer. The solution is just 4-line. Just 4-line. You have to do nothing. You have to just write the solution. It should be of this form, substitute and get it, and just 4-line answer. You can predict the behavior of this u1. Okay, so I just wanted to cover this because I think it is somewhere applicable. Yeah. So through this, I think we can pause it here.